We want to complete the table using the function rule f of x equals the absolute value of x plus 2, and then use a table to graph the function. And if we found it helpful, we could replace f of x with y and write this as y equals the absolute value of x plus 2. But over time, we should get more comfortable using function notation here. So what we'll do is select x values, perform substitution, and then find the corresponding function value or y value. And every time we do this, we'll be finding a point that would be on the graph of the given function. Now, the more we know about the absolute value function, the better. This is going to be a V-shaped graph. One thing that's helpful to know, though, when sketching the graph of an absolute value function is, if we can determine which x value would make the absolute value 0, we want to select values that are less than and greater than that value. Notice when x is negative 2, we'd have the absolute value of 0. So I'm going to put negative 2 in the middle of the table, and then I'll select values that are less than negative 2 here and greater than negative 2 here. So I'll go ahead and use negative 3 and negative 4. These are smaller than negative 2, and then I'll also use negative 1 and 0, two values that are greater than negative 2. Now let's see what happens when we use these values. To determine the corresponding function value or y value when x is negative 4, we'd have to substitute negative 4 for x, so we'd have the absolute value of negative 4 plus 2. This is the absolute value of negative 2, which is positive 2. So the graph of our function would contain the point with an x-coordinate of negative 4 and a y-coordinate of positive 2, which would be this point here. Next, we'll substitute negative 3 for x, so we'll have the absolute value of negative 3 plus 2. Well, negative 3 plus 2 is negative 1. The absolute value of negative 1 is positive 1. So the graph of our function must contain the point with an x-coordinate of negative 3 and a y-coordinate of positive 1, which is this point here. And then when x is negative 2, y would be the absolute value of negative 2 plus 2. The absolute value of 0 is 0. So our function contains the point with an x-coordinate of negative 2 and a y-coordinate of 0, or this point here. And then for x equals negative 1, the function value or y value would be the absolute value of negative 1 plus 2. Well, negative 1 plus 2 is positive 1. The absolute value of positive 1 is 1. So our function must also contain the point negative 1, 1, which is this point here. And then lastly, when x is equal to 0, we'd have the absolute value of 0 plus 2. The absolute value of 2 is 2. So our function contains the point 0, 2, which would be this point here. Now if we go back and take a look at why it's helpful to select an x value here that made the absolute value equal to 0, notice this created the point negative 2, 0, which was this point here, where the function actually changes direction. So when we selected points that were less than negative 2, we found points on this half of the graph. And then we selected x values that were greater than negative 2, we found points on this part of the graph. And now we can see the graph of our function is going to be a V-shape, and it would look something like this. Now I do want to mention that we didn't actually have to select these exact x values. We can select any x values that we want. But when it comes to the graph of an absolute value function, we would have to determine enough points to determine the V-shape of all absolute value functions. Notice if we only found these 3 points without these 2 points here, we might mistake this for a line when in fact all absolute value functions do form a V-shape. I hope you found this helpful. We want to determine the domain and range of the function f of x equals the absolute value of x plus 2 minus 3. The domain consists of all possible inputs or x values for the function, and the range consists of all possible outputs or y values for the function. Now there are a couple ways of determining the domain and range. We could use what we know about the properties of the absolute value function to determine the domain and range, or we could also make a graph of the function and analyze the graph. Let's start by analyzing the graph. So the first step would be to either make a t-table or use technology to create the graph provided here. Once we have the graph, we can analyze the behavior of the function horizontally and vertically to help determine the domain and the range. What I mean by that is, to determine the domain, if we were to project this function onto the x-axis, notice how it would include the entire x-axis. Another way to think of this is the graph continues to the right and continues to the left indefinitely without any holes or breaks. So the domain approaches positive infinity to the right and negative infinity to the left. Therefore, the domain of this function would be all real numbers. Or if we wanted to use interval notation, we could use the interval from negative infinity to positive infinity. Now, to determine the range, we would have to project the graph onto the y-axis or determine how the graph behaves vertically. Notice how the lowest point on the graph is this point here with a y value of -3. And then from here, of course, the graph is moving to the right and left very quickly, but notice how it's also moving upward. So if we projected this graph onto the y-axis, it would actually approach positive infinity along the y-axis, which means the range would be from -3 to positive infinity, and it does include -3, so we can say the range is greater than or equal to -3. Or using interval notation, it would be the interval from -3 to infinity, and it's closed on -3 because it does include -3. Now, if we didn't want to make a graph and we knew a lot about the properties of the absolute value function, we could use reasoning to determine the domain and range. What I mean by that is we could think to ourselves, what are the possible values of x that we could use to substitute in here and then evaluate the function? And the answer is we could use any real number here, add 2 to it, take the absolute value, and then subtract 3. And that's the reason why our domain is all real numbers. And then for the range, if we knew the absolute value of a number is always going to be greater than or equal to 0, well, if this is always greater than or equal to 0 and then we subtract 3, then the function value or y value is always going to be greater than or equal to -3. Again, if this value right here is always going to be 0 or some positive number, then the function value or y value must always be greater than or equal to -3, which is our range. So I know it can be challenging to just think about what the domain and range would be given the function. So I think it's always helpful to sketch a graph of the function and analyze the graph, if nothing else, just to verify the domain and range.